why the some of the instruction replicating was a complete failure. Okay, so why? But before we get to that, actually, let's go one step further back and talk about, well, how did you produce your instructions in the first place? Okay, so how many of your instructions only involved words? Okay, so let's just take a quick count. How many people? Hands up if you had roughly just words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 just words. Okay, how many had just pictures? Or primarily pictures? Okay, 2. Okay, and then the rest of you, what did you have? Kind of a mix of the two? Yeah. Brad, did you have something different? So that's one, two, three, four, five. Yeah, okay. 5 mix of both. Okay. Now, how did you get away with that? Well, did I ever tell you that you had to only write or draw or whatever? I just said produce instructions. Okay. Now, of those of you who received instructions that were just words, what kind of success did you have? Okay, so of those who received just words for your instructions, how many would you say it was pretty good, pretty spot on? Okay, so three, four, four, five, six, maybe. All right, so let's say we'll call that 6 of 12. What about those of you guys who got pictures? Oh, well, did it turn out okay or not? Yeah, okay. Well, like, whose was the source? Yours? Okay. All right. So that's one. Thomas, who ended up with yours? Okay. How did his turn out? Good? All right. So let's call that 2 out of 2. Um, yeah, this is a better ratio than a Fiji party, right? Too soon? Yeah. All right. What about the mix of both? Okay. So you five, how did yours turn out relative to the initial prototype? Good? Too good? So 2 out of 5? Yeah. Okay. So 4. It, all right, we'll call it 4 out of 5, right? All right, so um, what's the maybe the moral of the story here? Huh? Yeah, picture books are great. Okay, um, yeah, fair enough, right? But there are lots of different ways that we could explain or write down the instructions for producing a paper airplane. Uh, and in a sense, those 12 of you, or maybe let's start with the two picture versions, right? The way that you did that probably was very different from each other, okay? The two instructions, even though they were both in picture form, okay? Um, so the you think of this in a sense as you guys have just written a program that somebody else executed for producing this particular paper airplane, and you made up a language on the spot. Okay, now maybe it was mostly English. Okay, but uh, we were kind of joking as you guys were doing this. How many of you guys use sort of technical or quasi technical terms when in your written instructions? Okay, so how many hamburger and hot dog folds did we see in them? Did we have those? Yeah, okay. And then if you received a set of instructions that said to fold hamburger style or hot dog style, did you know what that meant? Okay, how did you know what that meant? Huh? You've been alive for 18 to 21 years. Okay. But also, at least from elementary school, that's how I remember us talking about folding stuff, right? Uh, I also remember in what was it, fourth grade, we made latitude belts and longitude ties. Yeah, out of like construction paper. It was real cute. No, yeah, latitude belts, longitude ties. Yeah. Okay. Anyway. Um, right. So never specified how to produce the instructions. And you guys just all came up with something. And I'd say for the most part, that they ended up being relatively successful. Okay. So let's think about kind of the components of the instructions. Okay. In this particular case, the instructions were basically do this, then do this, then do this, then do this, right? So your instructions were essentially just a sequence of imperative expressions. Okay, do this, then do this, then do this. Okay, um, probably was not the case, at least in the paper airplanes, that you had. Uh, did anybody ever have the word if or then in your instructions, or some sort of pictorial equivalent? No? Okay. So, okay, my brain just crashed. I've been up for 248 days, so um, conditional, that's the word I'm looking for. Okay, so in our case, we definitely had lots of imperative expressions. We didn't have any conditional ones, or at least not in the instructions you produced, okay? And that's mostly just because of it wasn't necessary for this. Did anybody have anything that was something where you said repeat or do this X times or anything along those lines? Did anybody have those in their instructions? Okay, how did you have that? Okay, right. So flip over and then repeat some procedure. Okay, so we did have some of those. Okay, and the repetitive things could be a specific number of times, like in your case, just once, right? Repeat this procedure or do the procedure twice, once on one side, once on the other. Okay. Um, so, Thomas, you mentioned that you did something like this in elementary school with making peanut butter and jelly sandwiches. Okay. So, what was were there instances where you had conditional or expressions with the peanut butter and jelly? Repetitive, yeah. Okay. Because what was the repetitiveness there? Mm, I'd say that spreading peanut butter on one piece of bread is not a repetitive thing. It's a single instance of something. Okay, fair enough. Spread the jelly instead of the peanut butter. Okay, but also where in the sandwich making process might you have repetitive things? Well, what about if I asked you to produce 12 peanut butter and jelly sandwiches, right? Do you need to give me explicitly the instructions for each of the 12 peanut butter and jelly sandwiches? No. You need to give me one set of instructions for how to make one peanut butter and jelly sandwich and then tell me to do that 12 times. Yeah? Okay, what about a conditional expression? So, where in the peanut butter jelly world might you need to make a decision? Yeah. Right. So what happens if you run out of peanut butter or you run out of jelly or you run out of bread or the person you're making the sandwich for is allergic to peanuts or something, right? Like you might have to make a decision making process that was conditional on some thing being true or false. Yeah? Okay. So these three kind of things are essentially what every computer program is built out of in any language. Okay. Uh, Imperative expressions. So those are going to be things like letting a variable have a particular value or adding together two values or doing arithmetic or something like that. And then the way you control the flow of this is by having repetitive instructions and conditional things. So if something is true, then do that. Otherwise, do this other thing, and so on. Okay. And we'll look at how we express these things or how we could write these things in an actual programming language to kind of see what they mean and how to think about them. But we don't have to actually be programming, so to speak, to be using all three of these things, right? The peanut butter jelly, the paper airplane, right? You guys had no problem with those ideas. Okay. Now, as for the instructions, let me go over to the computer for a second, because I'd like to look at a set of instructions that you probably all have used in some way, shape, or form in your life that are 100% pictorial. Any guesses? Origami, good guess. IKEA, okay, also good. How many of you guys have built something from IKEA? Yeah, which means not only do you need the instructions, but you also need the little Allen wrench, right? The hex key, right? Well, okay, come on. I'm at a college for men, and for you guys to be men, you had to first be boys. And what do boys play with? Legos. Yeah, okay, fine, right? All right. So here's a picture of uh, a Lego set instruction manual. So I bought this set over the weekend because I'm a giant nerd. And here's the set of instructions, right? 2x, that's kind of a repeating thing. It's telling me I need that many pieces, right? It's got the little arrows. Those are kind of handy, right? And then what does it say here? Do it twice, okay? So I build two of those using these instructions, and then I add them to what I had before. Okay, so Lego instructions. Uh, why do we make these pictorial like this? Okay, that's definitely one benefit, right? Lego is a multinational company. Children from all over the world, um, both boys and girls, right? I'm not discriminating here. Play with these when they're kids, and if you used lots of words in them, you would have to translate them for every country and every language that you're going to be marketing the product in. Okay, so that's certainly true. What else? Exactly, right? The two things, right? So this is a set, this particular set, that probably only adults are really going to want this particular set, right? Um, or if a kid does, it's not going to be a younger kid. So, point being, the children that might be putting this particular set together are perfectly capable of reading instructions written in English or whatever language, right? But if your children, right, particularly if you're younger children, you don't have to be able to read to do this, okay? With the exception, of course, of the numbers, right? Now, obviously, though, this set, like, how old do you have to be before you can recognize at least the basic numbers like one, two, three, four, and so on? Well, or recognize them in writing. Let's maybe say that, right? When did you guys start to learn to read? Huh? Yeah, you're 4 or 5, somewhere in there. Maybe a little, plus or minus a little bit. Yeah. Okay. So point being, you could give this set of instructions, or maybe not this particular set of instructions, but if I had like a race car or something, I could give that to a 6-year-old and expect that they would be able to work through it and produce the little race car, right? Okay, so yeah, so the reason that Lego does all this, and then also the point that was raised, which is this picture is worth, well, 1,000 words, right? It's way easier to explain what you're doing here in this picture format than in some sort of English or other, written language. I mean, how would you even begin to do this in just English? It'd be kind of a nightmare, right? Yeah, but this language is much better suited to the task, and it's a language that I mean, I can't speak to everybody's childhood, but Lego was sort of the central toy of my childhood, um, and so I got very fluent, if you will, in this language. Okay. Um, Now, what's hilarious is, so maybe about, oh, so my parents just retired and they moved. But in the decade leading up to the retirement, they started kind of trying to clean out the house of all of my stuff and my sister's stuff from when we were kids. And in particular, we still had every single one of my Legos in big plastic bins. Um, and those are things that should not go to garage sales, guys, because that's your childhood right there. Um, your Lincoln Logs can go to the garage sale, but your Legos, those are for life. Anyway, so they're like, we want you to take all your Legos. Well, finally, I have a house where I have room to store these things. So the next trip down to visit my parents, I'm loading up the car with the things. Um, but what my parents found especially hilarious, maybe, 7, 8 years ago, when I started actually using Lego stuff in teaching, they're like, oh, finally, we get the payoff. Turns out all that money we spent on Legos on you as a kid was all just job training. So, yeah. Anyway, okay, so right, we've got this particular set of instructions. Now, if I want to write a computer program that's going to connect to a web browser and do some stuff, is this the language I want to use? No, this language is fantastic for building stuff, but terrible for other things. Okay, and as one could imagine, there are other things for which the pictorial kind of representation would be a complete disaster. Okay. Um, okay. So that's basically the idea of what we want to kind of talk about uh, moving forward. Okay. Are all of these kinds of things. Okay. And with repetitive expressions, so I'm going to add in maybe here functions as one. Okay, and I'd say that we didn't have any functions in our paper airplane examples. Although you could regard your set of instructions as being a single function on its own. Okay, fair enough. In the context of Lego, you might say this. So let me actually go back to the instructions. So one of the things that they've started doing um, with Lego instructions that's a little different than when I was a kid is the bags that all the parts come in are numbered, and the parts are sorted into various bags, and then you know that, okay, if I want to build the little globe stand, I'm going to need bags 1 through 4 for that. And if I'm going to make the equator ring, I need bags 5, 6, and 7 for that. And then to build the upper hemisphere, I need these bags. Presumably to build the lower hemisphere, and to put it all together, I need those bags, right? They didn't used to do that when I was a kid. You just had to dump it all out and find the pieces. So, yeah, we also had to walk uphill both ways in the snow to the Lego store, right?
In the start of the instructions manual, there was the pictorial instructions to dump out all the bags and sorts into columns.
Which this is sort of replaced in some sense,
Yes.
right? Um, okay, so um, right, so this particular set of instructions, right? We could argue in some sense that building the top hemisphere, that is a function. It's sort of like a miniature program. And then building the stand or the equator or whatever, those are themselves other functions. And we've kind of put these things together. Um, okay, so we might say that. But the thing that'll be interesting about functions is that they can be self referential. Okay, and when we do this, this is called recursion. And we will spend a lot of time talking about recursion because it will give you headaches. So, in your assignment over the weekend is to make sure you have plenty of whatever your favorite headache medicine is, because you're going to need it. Okay. Yeah. So if you're if you're team ibuprofen or team Tylenol or team naproxen sodium, right? None of you freshmen should be taking aspirin. You're still too young. Um, huh? Oxycodone. Damn, son. Yeah, give me a little something of that. I'll pop one of those before the next faculty meeting and be like, woo! Yeah. So, yeah. Okay. So, yeah. So we're going to kind of talk about each of these things in turn. And the imperative expressions are maybe the easy ones. Um, okay. Because they're just a single instruction to do something. All right. So let's do sort of imperative. We might call these declarative. Okay. So it could be stuff like let x equals 5 or y equals x plus 7 or, um, you know, area equals my function of triangle 1. I don't know, I'm just making stuff up here. Okay, so single instructions that do something, right? There's no asking, should I do this? Should I not do this? I just do it in order, okay? And in the case of a computer, right, which is what we're here to talk about, we're not here to make paper airplanes and peanut butter jelly sandwiches, as much as those are fun. Uh, in terms of a computer, a lot of these things are going to be mathematical or logical uh, or data transfer kind of operations, right? Do this to this particular piece of data, do this arithmetic, do this logical operation, or move this piece of data from here to there, or something along those lines. Okay. And the exact language that we write this in, well, like I've kind of mixed apples and oranges here, right? The first one I've got let, right? So I can still have English kind of present in it. And in fact, some languages like Python um, do have little bits of English that are kind of sprinkled about. And part of the reason for that is to make the language more readable and less technical looking. Okay. But, you know, I could end up having something like, um, well, let's just say this. That instruction. Does that mean anything to you? No. Okay. Because you don't know what that language is, right? So, this is, by the way, an instruction in AArch64 assembly, which is a preview of coming attractions to CS-241. Those of you guys who want to be CS majors, yeah, you're a senior. Well, we don't have to graduate. You could just like not, right? Not. Yeah, you'd need another 3 years. Just graduate. You don't have to go home, but you can't stay here. Um, okay, so uh, for the sake of sort of talking about these sorts of ideas, okay, we will essentially use Python style notation. But the fact that it's Python, the fact that I'm going to write stuff sort of looking like it's valid Python code, um, is not particularly important. Um, it's just that Python is sort of the easiest way to write this stuff because it doesn't have lots of curly braces and semicolons and other really technical looking uh, things. Um, so that's reason number one. Reason number two is that if I write stuff in Python, then we can think through on paper what should happen if we run through these sets of instructions. And then we can also have the computer do them and check to make sure that we get the same answer, right? And then the third, hang on a second, is, well, how many of you guys are planning to take more computer science? All right. So what course should you take next? Yeah, 111, which guess what that is? A Python programming course. Okay, so it'll be good. You're not learning full blown Python with what we're going to do, but this way, when you get into 111, you'll be already kind of familiar with what it looks like. Yeah.
Um, I've heard that Python is a great language to start with because the formatting and spacing is part of the code, and
Mhm.
so it helps you keep your code clean, cleaner, working
Yes,
well.
and that's maybe the another reason why I'm going to kind of use Python style writing, is because Python. Think of Python is to computer programming what Lego language is to like building instructions, right? It's particularly well suited to beginners because there's not a whole lot of technical formatting, right? And the formatting that is present is done in a way that makes it very clear what the structure is, okay? Which is why it's a good language for beginners, right? If I threw C at a bunch of beginners, okay, it would be a little painful at first. It'd be because there's a very steep initial learning curve. Okay. Now, what for those of you guys who have done some programming in any language whatsoever, what languages were those in? So, has anybody done a little bit in Python? Okay. What else? What other languages? Did anybody program in like the any of the graphical languages like Scratch or MakeCode or Lego's robotics language, or did Vex or something in high school? Yeah, where you're putting together little blocks of code in some sort of arrangement and dragging wires and things in between them. Yeah, which languages? For what? For Vex? Okay, yeah. So Scratch, these are examples of, and in fact, I'll just show you what it looks like um, here real quick. Okay, so Scratch, I'm just going to pick a random, somebody's random project here. Okay, this is what it looks like, the sort of style of code. You're putting together little blocks of things, um, almost, I honestly, as if you're building Legos, which is kind of neat, right? The paradigm of building blocks is actually handy. Um, Lego has a variant for its sort of robotics stuff that looks a lot like this. Um, and these languages, these block based things, these did not exist when I was a kid, which is unfortunate. Okay. So my first language, oops, was BASIC. Okay. So the beginner's all purpose symbolic instruction code. So this is the language I first learned. Uh, for x equals 1 to 10, print hello Wikipedia. Next x, you had line numbers. In particular, one of the reasons this was my first language was because, well, two things. It came with every installation of Microsoft DOS, which was the operating system that PCs used back then. Second is, how many of you guys had or have a TI graphing calculator? Has anybody programmed their TI graphing calculator? You have. Okay. Just a little bit. Okay. So we did this all the bloody time. So in eighth grade, everybody that was in algebra class, we were issued TI graphing calculators by the school, and we could program them. And so what did we naturally do? We put games on them, right? Okay. So we programmed little games. Some of them were text adventures, and some people got pretty good and made like a snake game or something, cheesy, or Tetris or whatever. Okay. But we also programmed things that, well, they weren't technically cheating, but uh, I programmed the quadratic formula, right? Like, of course, I'm going to do that. And then I got real fancy because I made it be able to handle the case when you had a negative discriminant and so you had imaginary numbers or whatever, right? It could handle that just fine. Like, yeah. And, the teachers let us get away with that. Why? Because were we really cheating? No, we thought we were, but what we were actually doing was learning way more, right?
We are now.
Yeah. Okay. And exactly, look where I am now. Um, the other reason I learned basic, so I'll finish with this, is in eighth grade, I was the teacher's aide for my algebra teacher, which meant I didn't have gym class, and instead, seventh period, I basically was her teaching assistant. So she was giving all of her non algebra class, so her regular classes, the following puzzle. You have the digits 1 through 9, and you're going to put them in boxes. Okay, and this arrangement is incorrect, so that if I this arrangement, I want 1, 2, 3 plus 4, 5, 6 to actually equal 7, 8, 9. Now it doesn't work in this case, but could you move the digits around and find arrangements where the addition would actually work? Yes. So she gave this puzzle to her class on a Friday and said, and then there was like a big candy jar, and everybody had to come back on Monday and write how many solutions they were able to get up on the board, and whoever ended up with the most out of each class got like a small candy thing, and whoever had the most out of all the classes got a big candy thing. So Monday rolls around, and people have found 5, 10, and I asked Miss Gurley on Friday, that was her name. It's like, can I try this puzzle? She's like, go for it. And so I'm, doing some work or whatever, and they're going through, and I think, somebody got 12 in the class. Ooh, 12. And then somebody was like, wait a minute, Miss Gurley, didn't Colin do this too? Yeah. Colin, how many did you get? Huh? I got all of them. I forget the exact number, but I found every single one. Okay. Now, how did I do it? I programmed a computer to search for all of them. Now, looking back at it, I programmed in the worst possible way to do it. So, about 6 months ago, the last time I told this story, I sat down and I was like, you know what? Now I have a PhD in math and I can think a lot smarter as to how to solve this. Okay. And so I sat down and recreated the solutions and found all of them in about 15 minutes instead of the several hours it took my computer back then to churn through them. Okay. But I programmed the thing to find all of these in BASIC. So I got home and I'm like, Dad, I need a book on BASIC. I need to do this thing. And he's like, well, we don't have a book on BASIC. So off we drove to Barnes and Noble to, right. That's what you had to do back then. Yeah. So anyway, all right. I will see you guys on Friday and we will continue this fun and exciting discussion.